Hello, my name is Hasan Seyit Soylu. I will present logic gates in Nasrettin Hoca Academy. We will use Proteus for the designs and making circuits. Let's start. As you can see, I have previous projects. As you can see, there's recent projects in here. I have a file. Let's click on that. And as you can see, we have it. We will not use these components. I delete these ones. Sorry. Let's add our gates. For the first, we have to we can add not gate, as you can see, and we can add the logic gate, logic input and output. We type logic and let's start to research. As you can see, we found it. It says logic state source. It's we can say it's input, and we can say the output to state indicator. Let's pick it and pick another one, and let's select to electronic version of the gate, the components. What we can pick, let's pick cell, or we can type battery. Yes, I want this one, and we can select switch. Yes, let's first switch. Yes, I found it, and we can pick redlet. Sorry. As you can see, we have redlet, and we can pick resistor for the led. Yes, we can pick any type of resistor in here. As you can see, we picked all the stuff, and let's make our first logic gate, not. How does not working? Let's make the states and logic probes. As you can see, did they connect? Let's. Yes, it's connected. This one too. Let's start and learn how does not gates working. As you can see, if the input is 0, the output will be 1. The 0 means that there is no electricity, and it can explain the ground. And the 1, as you see here, 1 can explain the 5 volts, or there is volt in here. They explain and acting like that. If I make the input 1, as you can see, the output will be 0. Not gate acting like what if the input is the reverse of the output. They are not can be the same. They always be different. As you can see, let's make the not gates electronic version. We can add cell to it. Let's stop the circuit, and we can add led and switch to here. Let's rotate it. As you can see, the longer part of the battery, as you can see there, is positive part of the battery, and the smaller and smaller part is the negative part, and let's start the beginning of the if you see this straight wire in here, that means this is negative pole, and the start of the, as you can see, there is a triangle here. The beginning of the triangle is a positive pole. Let's make the connects. Let's add an resistor circuit to not exploit the LED. Let's make the change the resistance. We can make it 330 and make the battery 9 volts. Yes, we can start it. As you can see, if our let's change it. If our switch is open, so it means that it's 0. The LED is shining, so the output is 1. There is electricity in here. If I close the switch and make the input 1, it means that the output and the LED not shining, and output will be 0. The meaning of the circuit, electricity comes here. If you want to see the electricity, you can make where was it? Let's found it. Was it here? No. Where was it? I cannot found it right now. Whatever. uh, it was it template. I think no. Whatever. Forgive it. Let's learn the circuit. The electricity comes here, and the resistance will be decreased in here because of the resistor, and it's come here. As you know, the electricity flows in lowest resistance, and there is resistance that red LED has, so there's no resistance in the switch, so the electricity will go there and complete the circuit. But if I open it, if I open the circuit, the electricity cannot flow here, and it has to go off that way, and it shines the LED. It was the not gates principle. Let's make it different a little bit. As you can see, we can connect these NOT gates from each other. Let's make another output. As you can see, my input was 1, but it comes here, and NOT gate is the different from the output, so the output will be 0, and it comes here, and the beginning of the NOT gate it's 0, so it will be 1. If you make, if the NOT gates are singular, it will be the same result. I'm sorry, if the NOT output will be same, but if they're not, for example, we have 3 NOT gates, the output and input not will be same. They will be 0 and 1, or 1 or 0. It's nonsense, but I want to make it. Let's make another circuit. We can make AND gate. Let's type AND, and as you can see we have it, and I press OK. As you can see we have the AND gate. We putting our output, and we have, as you can see, two inputs. Let's connect them. Let's start our circuit. As you can see, if the inputs are 0, the output will be 0, and let's make one of them 1. As you can see, the output not will be 1. Let's make two of them 1, and as you see, the output will be 1. Let's make the AND gates electronical version. Let's put a cell, and first let's stop the engine. Let's make the battery 9 volts. Yes, and yes, we can put switch in here. Yes, let's put resistor to here. Are they connected? Nope. That's deleted, yes. Let's put red LED. Connect them. Let's change the resistance of the resistor. 330. And as you can see, if I start the engine, if the switches are 0 and the inputs are 0, as you can see, the LED is not shining and the output will 0. If I close one of the switch and make one of the inputs 1, it's not will be 1 and the red will not shine, but I make two of them 1, the LED is shining and our circuit will be working. Let's make 3 AND gates. As you can see, I put them, and let's make our inputs. And let's connect them, and let's put an output. Let's start the engine. As you can see, if there is no 1, it's not will be 1. If I make one of them 1, it's not will be 1 because there is zeros in here. If there is 0 in the inputs, the output will be 0, and whenever if all of the inputs are 1, as you can see, the output will be 1. If you put here 100 AND gates and make one of the all inputs, as you can see, if we have 100 AND gates, we will have like 40 inputs, and if in that 40 inputs, if we have 1 0, and the output will be 0 because AND gate it's working like that. If there is 1 in the input, the output if there is 0 in output, the output always be 0. Let's finish our first lesson of the logic gates. Thanks for listening. The next lessons, see you in the next lessons. Goodbye.